So we will have a free radical. Free radical addition reaction. Right. Now, what do you mean by free radical addition reaction? That's the point. Just see. So what do you think we'll have? Understand. This reaction is actually given by in the presence of in the presence of peroxides. In the presence of peroxides. Are we understanding? So if you are doing this in the presence of peroxides, what would that mean? Just see. If you are doing this in the presence of peroxides, what would that mean? Just understand. तो हमारे पास इसमें कहानी क्या है? That let's suppose we have an alkene, like we have this, and I have this reaction HCl, okay, or HBr. Okay, first of all, it is just conducted only with HBr, nobody else. And then when we have it, yes or no? And then when we
Mm.
have it, what would that mean? In the presence of some peroxide, we're going to have CH3, C, O, O, C, CH3. So we're going to have this. Yes or no?
Yeah.
So what do you think we'll have? So we'll have a benzoyl peroxide. This is the structure of benzoyl peroxide. We'll have a benzoyl peroxide. So what is a benzoyl peroxide? This is actually going to be a benzoyl peroxide. Okay. Now, what is the importance of this benzoyl peroxide group?
Mm.
Importance
Not
of this
sure.
benzoyl peroxide group, just understand that we will have this and this. Yes or no?
Yeah.
Right?
Huh.
Got the point? So, what do you think we'll have? So, we'll have this bond, and this bond is actually going to break down.
Okay.
This bond is actually going to break down. Yes or no?
Yeah.
So, when this bond is actually going to break down, so basically O here takes its own electron, and this cross also here takes its own electron.
Mm.
Yes or no?
Yes.
So, what do you think we'll have? So, we'll have this benzene. We'll have this, and we'll have this. We'll have this, and we'll also have this. So we have, how does this bond breaks? This bond basically breaks homolytically.
Mm.
This bond breaks homolytically. Are we understanding? So
Yes.
so when this bond breaks homolytically, what exactly does that? Just tell me. That when this bond is actually breaking homolytically, we will have this electron, and we will also have this particular electron. Understood my point?
Right. Yep.
Got it. So I
Yes.
hope you're understanding that this. So understand one word, HELPR. In the presence of heat, in the presence of electricity, in the
Light
presence of
peroxide and
light,
radical.
right, light peroxide and radical, we have the free radicals being generated.
Mm.
And I have told you the bigger the free radical, the more stability it carries. So we'll have bromine, and bromine will carry more stability. Are we
Yeah.
understanding? So bromine will carry more stability. Understood my point or not?
Yes.
Right. So understand one thing. So how do we have this? So we are going to have this CH3, C, double bond CH2, okay, plus HBr in the presence of some peroxide ROOR dash.
Okay.
Yes or no?
Yeah.
Right?
Mm.
Got it. So how do I break down ROOR dash? We'll have this electron, and we'll also have this electron.
Yeah.
Yes or no?
Mm.
So if I heat it up, this breaks. Now this RO feedback does what? We'll have an HBr, right? Now, in the presence of
Okay.
heat, it is actually breaking down. You understand. H free radical is stable, or Br free radical is stable? You tell me.
Br free radical
Yeah. So that means this H free radical being smaller
is
and
highly
unstable.
unstable.
Yeah. So what does it do? It basically makes a bond with H. So we have R O H and we'll have a Br free radical. Understood my point?
Yes.
Right? So we will have this Br free radical. Understood my point?
Yeah. But why do we need the RO? Why can't we just heat the HBr and break it? Or will that give us ionic?
See, we will have two free radicals. If I break simple HBr, we will have two free radicals, no doubt. But one of them will be unreactive. One of them will be less reactive. One of them will be more reactive. Or one of them will be more stable and one of them will be less stable. Then what do you think is going to happen? So we're going to have an H free radical and then we're going to have a Br free radical. Yes or no?
Yes.
So what does that mean? Just tell me.
Oh, the
What
H free
does it
radical
mean?
will attach to the main chain
Yeah.
instead of the
So
Br
we'll
free
have an H
radical.
free radical and we'll also have a Br free radical. Understood my point or not?
Yes.
Got it. So the smaller one, the unstable one gets captured, and we are left with only more stable free radical.
Makes
And
sense.
this free radical decides how to kind of, you know, this free radical kind of decides how to solve this. So we'll have this free
Okay.
radical. Got it. So we'll have ROH plus a Br free radical. Yes or no? We will have an
Yeah.
ROH plus a Br free radical. So how does this bond? This Br free radical. So first step was this. Second step was this.
Hmm.
All right. Second step was this. Now, when we have the
All right.
second step, what would that mean? Just tell me. What would that mean? So we will like we're going to have a ROH plus Br free radical.
Hmm.
Got the point?
Yeah.
So when we have an ROH plus Br free radical, what would that mean? So we have this, right? Now the Br free radical attacks what? Now
The
we have the
carbon.
third step. We have CH3, CH, double bond CH2
Hmm.
plus a Br free radical. Now what does that mean? So we're going to have this bond here and a here.
All
And when
right.
BR attacks here, what do you think is going to happen? A cross will come here and a dot will come here.
Hmm.
So we are going to have a CH3, CH, and a CH2. A cross will come here and a dot will come here. And we will have a
Okay.
Br free radical.
Okay.
Okay? We will have a Br free radical. Now you
Hmm.
understand which radical is more stable. The one which has more groups connected to it. So obviously CH3 radical will have two groups connected to it. We have learned that.
Right.
It does not matter whether it is electron releasing group or whether it is electron withdrawing group. So
Withdrawing.
obviously the stable one should stay. So in free
Hmm.
radicals, it's never the case of 3 degree or 2 degree. It's always the case where more groups are connected to it, right? So,
Huh.
all right. So this is a stable free radical. And
Yes.
because it is a stable free radical, what would that mean? Just tell me that this Br will attack here. When this Br is going to
Okay.
attack here, so we're going to have CH3, CH, and a CH2. And here we have a Br. Why? Because Br gets its own electron and CH2 cross gets its own electron. Are we understanding?
Yeah.
Right?
Huh.
So we'll have this. And this is the free radical which is generated, which is my 2 degree free radical. Now you understand it's a very, very important part that once we have this Br,
Hmm.
what would that mean? Just tell me. So we'll have a CH3, CH, CH2 free radical. Understood my point or not?
Yes.
So once I have the CH3, CH free radical, what would that mean? We'll have a CH2, CBr, this kind of free radical we have. Are we understanding?
Hmm.
Are we understanding? So once we have
Yes.
this scenario, what would that mean? Right? So we'll have a 2 degree free radical.
Hmm.
Got the point?
Yeah.
Got it?
Hmm.
Now, what happens is then we have another molecule HBr. Again, this free radical now. This free radical needs one more electron to complete its octet. Yes or no?
Yes.
Got the point? And
Yeah.
then when this attacks, it is actually going to break the bond in such a way that we'll have what?
Okay, so now the edge will attach here. So the
Yeah.
first time we eliminated the edge using the arrow, but the next time this it gets the edge in.
Yes.
Okay.
So you're gonna have a CH3, CH, and a H, and a CH2Br. Understood my point?
Yes.
Got the point or not?
Yes.
Yes or no?
Yep.
So we will have this free radical. So I hope you're understanding that what do you think we'll have? So we'll have a CH3, we'll have a CH2, and we're gonna have a CH2Br. That's the product. अब आप देखो अगर आप HBr को normally break करते हो, so
हम्म
what does that mean? अगर आप HBr को normally break करते हो इसका मतलब क्या है मुझे बताओ.
पहला जो
इसका
एच है
मतलब क्या है?
वो जाके कार्बन पे अटैच हो जाएगा
हाँ तो
एंड
नॉर्मली हम ये बोलते हैं कि जो Br नेगेटिव है दैट इज अ नेगेटिव एंड,
हाँ
दैट इज द नेगेटिव एंड ऑफ द reagent HBr.
ओके
अगर ये उसका नेगेटिव एंड है ऑफ द रिएजेंट इसका मतलब क्या है मुझे बताओ. अगर ये नेगेटिव एंड है ऑफ द रिएजेंट इसका मतलब क्या है बताओ. कि अगर ये
कि
नेगेटिव एंड है रिएजेंट का इसका मतलब क्या है. बोलो.
अनायनिक है वो
हाँ. तो हम नॉर्मल मार्कोनिकोव रूल में क्या पढ़ते हैं. हम पढ़ते हैं जी मार्कोनिकोव रूल में दैट द नेगेटिव एंड ऑफ द नेगेटिव एंड
हम्म
ऑफ द एडिंग रिएजेंट goes to the carbon with
which is most
less number of
substituted
hydrogens. Yeah, less number of hydrogen atoms, or I would say more substituted carbon atoms.
ऑलराइट
Yes or no?
या
या हाई डिग्री का कार्बोकेटाइन जो भी होता है. तो हम कह रहे हैं
हम्म
यहाँ पे क्या हो रहा है. यहाँ पे जो नेगेटिव पार्ट दिखता था पहली बात तो यहाँ हेटेरोलिटिक डिकम्पोजिशन नहीं हुई. यहाँ पे जो
हाँ
डिकम्पोजिशन हुई वो एक होमोलिटिक डिकम्पोजिशन हुई अंडर द इम्पैक्ट ऑफ अ फ्री रेडिकल. ठीक है जी बहुत
राइट
बढ़िया. ये जो फ्री रेडिकल अपने पास है, ये जो फ्री रेडिकल अपने पास है, ये फ्री रेडिकल क्या करेगा मुझे बताओ. ये फ्री रेडिकल हमारे HBr पे अटैक करेगा.
हम्म
तो जब ये इस पर अटैक करेगा तो यहाँ से एक फ्री रेडिकल ले जाएगा.
राइट
ये था नो. और
हाँ
अगर वो यहाँ से फ्री रेडिकल ले जाएगा तो हमारे पास प्रोडक्ट क्या बन जाएगा. ये आ जाएगा CH3, CH, और ये आ जाएगा CH2, और यहाँ पे क्या आ जाएगा मुझे बताओ. यहाँ पे हमारा H आ जाएगा और यहाँ पे Br आ जाएगा. तो दैट्स एक्चुअली गोइंग टू बी माय प्रोडक्ट. तो ये एक एंटी मार्कोनिकोव रूल है.
ओके
ऑलराइट. एन एंटी मार्कोनिकोव रूल इज आल्सो कॉल्ड एज व्हाट.
नो क्लू
It's also called as Kharash effect. All right.
ओके या
Any doubts in this?
no so
Sure.
if we were to just heat HBr so HBr is ionic right and if we were to heat it would we get H plus Br minus or we would get free
HBr
radicals
is
itself
not ionic, first of all. HBr is not ionic.
right my
Okay.
bad but there's an
Yeah.
EN difference there
There's an electronegative difference there. But HBr, you understand that this is actually what is the electronegative difference with regards to HCl and HF? Do you find any electronegative difference there?
in LCl and HF yeah
Hmm.
a much bigger difference than in HBr
Definitely. So then that is why that the when I started this process, I said that it happens only with HBr.
okay
Why? Because that difference is not too much. So the moment you heat it, you can break it into a free radical.
all right
Okay? That's the idea
yeah
we have.
fine
That's the idea we have. Understood my point?
yeah would HI do it in this case like work with it
HI will not do, HCl will not do. So if you give HCH3, CH double bond CH2, and you have an HCl here, and you have an HCl here, you understand? So in
it
the
will
presence
become
of
H plus
R,
Cl
O,
minus
O, R dash. So what exactly do you think is going to happen? So you're going to have this. So this bond is actually going to break. And when this bond is actually going to break, in this example, even if the peroxide is present, HCl will do the same Markovnikov addition. Negative part will go here, positive part will go here. So we'll have a CH3, CH, and Cl, and CH3. Are we understanding? So the negative part will go to the carbon having. So the negative part will go to the carbon having less number of hydrogen atoms, normally जो हमारा मार्कोनिकोस रूल होता है उसी को ये फॉलो करेगा।
अच्छा।
आर वी अंडरस्टैंडिंग? तो क्लोरीन को
हाँ।
कोई फर्क नहीं पड़ रहा कि यहाँ पे पेरोक्साइड पड़ा हुआ है, आर ओ ओ आर डैश पड़ा हुआ है, या क्या पड़ा हुआ है, एब्सोल्युटली नॉट एन इशू। ठीक है,
हम्म।
कोई इशू नहीं, फर्क पड़ेगा उसको, बस ये है कि भैया हमारे पास ये है।
अच्छा।
गॉट द पॉइंट?
Yes. And why do we use benzoyl peroxide sometimes and then, but it can work with any peroxide, right?
बेंजोइल पेरोक्साइड के साथ हम इसलिए यूज करते हैं क्योंकि एक पेरोक्साइड जो बन के निकलता है ना, ये बहुत ही स्टेबल होता है, रेजोनेंस कर सकता
अच्छा।
है ना। सो क्वाइट
Okay.
स्टेबल, दैट इज व्हाई।
Mm.
अंडरस्टूड द पॉइंट?
Yeah.
सो दैट्स द आइडिया वी हैव।
Okay.
ओके,
Yeah.
so that's the idea. So negative part will go to the carbon having less number of hydrogen atoms. That is going to be my Markovnikov's rule.
Mm.
Understood or
Yeah.
not?
Got it.
ठीक है, अब देखो
Mm.
नेक्स्ट। अब नेक्स्ट हमारे पास यहाँ पे क्या चीज है, देखो। सो दिस इज हाउ वी हैव, राइट? अब इसमें कोई रीअरेंजमेंट नहीं हो रहा, कोई कुछ नहीं हो रहा, ठीक है। सो दैट्स द आइडिया वी हैव। अब आप देखो हमारे पास इसमें कुछ रिएक्शंस आते हैं जो हमने इलेक्ट्रोफिलिक सब्स्टिट्यूशन पढ़ा था शायद से।